In Master of Puppet, we're going to be talking about how it is that we manage servers in our infrastructure that supports the applications that we're building. So one of the things that's useful to do is to look at where is it that we've been. Well, when we started out all of this work, we've been doing this for several years, we had servers that were handcrafted by artisans, if you will. Someone would own the server, they would build the server up over time, become the owner of the server. If the server got sick, they would nurse it back to health. Well, over time, as our needs scaled, we figured out that single people owning servers didn't scale very well. And so we moved into this idea of ad hoc scripting. Let's take the person and write a script to automate what it is that they do. When we have a new server, we'll simply copy those scripts to the server and let them run there. Well, over time, those scripts would start to diverge from one another, and we'd have not one person to worry about, one script. We'd actually have n different copies that were slightly different. So to rein in this problem, we moved to this idea of SSH in a for loop. Let's pull those scripts back to a single location, loop them over all of our servers, and execute them over SSH. And that kind of represents the state of the art. Where we're going is declarative infrastructure as code. Instead of telling a script what it is that or how it is that we want to configure the server, we're going to tell a tool what we want the server to look like and allow the tool to figure it out. This will enable us over time to be able to dramatically decrease the speed that it takes to rebuild infrastructure, which allows us to, as a friend of mine has said, stop treating servers like pets and start treating them like livestock. If it's sick, shoot it. Puppet is a tool that enables us to get into that space. It is a powerful framework for the automation of tasks that are typically performed by system administrators, the artisans that handcrafted the servers. What Puppet gives us is a couple of things. First off, it gives us a configuration language that allows us to very easily describe in a declarative way what we want our infrastructure to look like, what packages should be installed, what files should be present, what services should be executed. It then also provides us a resource abstraction layer. If I'm managing Linux systems, AIX systems, HP, UX, Windows, how I do the same types of things on all of those different operating systems is slightly different. So what Puppet provides is a resource abstraction layer that allows me to talk about packages and services, and it implements providers underneath those resource types that allows me to talk about them in the same way across platform and allow the tool to figure out how do I actually get this done. Some very important features of Puppet are the fact that it's idempotent. I can run the same configuration multiple times on the same server and get the same results, something I can't do with my ad hoc scripting. It's cross-platform. As I said, it works with most of your Linux variants, it works with other variants of Unix that you might find in the enterprise. It also happens to work with Windows. Puppet is model and graph based. It takes the resources that you have described and figures out, based on dependencies that you've declared, what are the relationships between all of these resources. So that's kind of the what Puppet is. The most exciting part of the talk is where we'll get to the end and we'll do an integrated case study where we'll take a web application that has no infrastructure behind it, and I will bootstrap servers in the cloud, configure them to have all of the necessary middleware that is needed for this application to execute, and deploy that application, do almost none of it manually, and execute it all in less than 30 minutes.